Good morning, Geometry Honor students. So Mr. Chen again. So today I would like to talk about Chapter 6. So it's all about that the segments inside the triangle. So like finding that all the perpendicular bisector, median, altitudes of a triangle, and also that the angle bisector. So anytime they see all those segments, they intersect inside the triangle. So we do have different type of concurrent point. Okay, so let's take a look at that. So centroid, that means it's being formed by all the medians of a triangle. So median, that means it's a line segment bisector. Okay, so if you see the triangles like this, so you see that the point here, the point where that all the medians that they meet. Okay, so the midpoint, so that means the segments, so those segments are considered congruent. So the segment here, they're considered congruent. So anytime they see all the medians, they all intersect. So the point here, it's called a centroid. So the ratios for the centroids, the ratio for the median would be 2 to 1. So let's say that the major segments of the median, the first median, so this one would be considered 2 for the ratio. The minor segment, so then that'll be 1. So the total ratio would be considered 3. So you can say that 2/3, 1/3, in order to get that the line segment. And then circumcenter, so perpendicular bisector of sides of triangles are concurrent at a point equidistant from the vertices. So let's say that all the perpendicular bisector, okay, so perpendicular bisector, so that means, well, what we got here, besides the segment, they're considered congruent here, so also it's considered perpendicular. So that forms a 90-degree angle. So anytime they see the concurrent point, so this one is called the circumcenter. So again, circumcenter is being constructed with 3 different perpendicular bisectors. And then incenter. So incenter, the bisector of an angle of a triangle meet at the point that is equally distant from the sides of the triangle. So angle bisector. So you see the angle bisector that they all intersect at this point here. So this one is called the incenter. And also you can see that there's like an inscribed circle here inside the triangle. Okay. And then orthocenter. Ortho means right. So the point where the lines containing the altitude are concurrent is called the orthocenter of a triangle. So the point that is being, the point of intersections of all the altitudes of a triangle. Okay. So this one is some of the practice problem you guys can do. Okay, so fill in the blank, all that. So we'll talk about that in a minute. Okay, so like the following problem. Finding the missing segments. Finding the missing segments if this point is a centroid. So how do we deal with this? And also getting the perimeter. Okay, so given that point D is the incenter of an isosceles triangle. And how do we deal with things like this? Okay, and then some other multiple choice questions. Okay, so we'll take a look at that. Okay, so now, so in order to construct that the centroid, okay, so you need to set up that 3 medians of a triangle. So the median, that means you want to allocate the midpoint of each line segments of the triangle, and then you just want to connect that from the vertex to the midpoint. The vertex to the midpoint, from the vertex to the midpoint. And then for the point where they meet here, this one is called a centroid. Okay, so the median. And then incenter, so 3 angle bisectors. So we got 1 angle bisector here. Here's another angle bisector. And here's the other one, angle bisector. So once you get all those 3 angle bisector and you find out the point where they intersect, so that would be the incenter. So centroid, so that means it's considered the point where all median meet. Orthocenter, so we talked about that already, so which is the point where all the altitude meet. And then circumcenter, so circumcenter, then that would be the point where all the perpendicular bisector of the side meet. Incenter, the point where all the angle bisector meet. So in the diagram below, so triangle TEM, median TB. Okay, so this one mentioned about the median. So the point here, it's always called the centroid. Again, the ratio would be considered 1 to 2. So 1 to 2. So in order to get that, the line segment TD, okay, so TD would be considered the major segments of that median TB. So the ratio here is 2 to 1. So that means the total ratio would be 3. So taking that 2 over 3 times the line segment of the median, the length 9. So 2/3 times 9, then you'll get 6. Okay, cross cancel. So here's another problem. So centroid, so that means they're all considered median. So of triangle ABC, so CZ is 18. So ZZ here is 18. So what's the length of segment ZF? Again, the ratio for this one is considered 2 to 1. So since this one is twice as much as the other one, so that means the other line segment, ZF, and then that's just like half of it. So 18 divided by 2, or 1/2 times 18, which is 9. So using the ratios relationship. And then point Z is a centroid again, so triangle ABC, so ZF is 5, so it's already labeled. AD is 12. Okay, so AD, the measure of the entire segment, is 12. And then BC, okay, so BC right here is 18. Okay, BC right here. And what's the perimeter of triangle DCZ? So DCZ right here. So in order to find out all the missing segments, so DZ, so again, you take half of that 8, okay, or you take 1/3 of 12, so 1/3 of 12, you'll get 4, so DZ is 4. And then for the other line segment here, like ZZ, okay, so this one, well, we do know ZF is 5, so this one is twice as much, so 5 times 2, then you'll get 10. Okay, and then DC, well, since we do know that this one they're all considered a median, so this one that means the midpoint, so half of 18, so then that'll be 9. Okay, so half of 18. So we got 4, 9, and 10. So basically just combine them all together. So then that'll be 23. And for number 4, so given that point D is the incenter of an isosceles triangle, so incenter, that means it's considered the concurrent point of all the angle bisector. So if this one is considered an isosceles triangle, okay, so one thing that we notice, so this one is 60 degree. Okay, it's already given, so it's 30, 30. And that means the rest of those got to be 60 and 60 as well. Because 180 minus 60, then that'll be 120. And then this one, since they're all considered angle bisector, so that means they're all considered equal. Okay, so for the angle. So 60, half of that would be 30. Half of this would be 30. So 180 minus 30 minus 30. Then that'll be considered 120 degrees. So what type of triangle would have its orthocenter on a triangle? So orthocenter, that means it's all the perpendicular altitude. So then that'll be considered the right. Okay, so what type of triangle? So right triangle. And which is the point of intersection of the median of a triangle? Centroid, we talked about that already. So 3 or more lines that contain the same point are called a concurrent. Okay, concurrent, not current, concurrent. Okay, so all meeting at the same point. And the incenter of a triangle can be located by finding the intersection of the line. Incenter, so that means it's the point where that all the angle bisector meet. Okay, so angle bisector. So here's another thing we would like to talk about here. So it's about the triangle inequality. So let's say that in order to have a triangle like the segment A, B, and C, okay, so A is the shortest leg, B is the median, and then C is the longest. So in order to validate that A, B, and C, the number, they're all correct. So there's one of the compound inequality we need to satisfy. I think we talked about a little bit like that before. So its absolute value of A minus B must be less than C, and it must be less than A plus B. Okay, so once we've been able to satisfy this compound inequality, so that means the triangle can be formed. If part of the compound inequality fails, so that means the triangle cannot be formed. Like this one here, so A is 2, B is 7, C is 10. So if you just plug into the compound inequality, so we do have 2 minus 7 with the absolute value, less than 10, it's less than absolute value of 2 plus 7. As you can see that this one, obviously, 10 is not less than 9. Okay, if you see anything like that happen, so that means the triangle cannot be formed. So like this one also, 4 plus 6, that's exactly 10. But we need to have something that's greater than 10 for the sum. So the triangle cannot be formed either. So this one, it works. Okay, so 5, A minus B, so 5 minus 7, it's less than 9 with the absolute value. And then less than 5 plus 7. So 5 minus 7, that's negative 2. Absolute value of negative 2, positive 2, which is less than 9. And it's less than 12. Okay, so this one is considered the triangle. And also this one too, 9 plus 5, that's what, 14. Okay, so which is greater than 13, so that it works. And then 5 minus 9, that's negative 4. Absolute value of negative 4, that's 4. So it's less than 13. So this one is quite similar, so just basically using that the triangle inequality theorem to find out the possible length. So subtract, so A minus B, or B minus A, so 7, and then B plus A, 13, so you got 7, it's less than X, it's less than 13. And you can always put it into the absolute value compound inequality. Okay, so this one, just like the one that we were doing. So absolute value of negative 7, 7, it's less than C, and it's less than what, 13. So that's just another way of doing it. And this one also, 12 minus 11, that's 1. 12 plus 11, 23. And then the rest of this, just find out the measure of the missing angle. So since we do know that the triangle sum theorem, all the measure of the angle of a triangle is 180. So 180 minus 47 minus 58, you got 75. 180 minus 96 minus 21, you'll get 63. And this one, 90 degree. So the sum of the other two angles got to be 90 degree as well. It's like a corollary of a triangle's sum theorem. So that one is 3x minus 1. So set that 3x minus 1 plus 31 equals 90. And then basically just solve for x. And then you'll get 20. And then the rest of this, so exterior angle theorem. So the sum of those two non-remote interior angle is the same as the measure of the exterior angle. So x can be found by adding 21 and 34. So exterior angle, so 21 plus 34. So then that'd be 55. And this one's similar, so 2x plus 3 plus 51, so that equals 100. And then solve for x algebraically, you got 23. And then this one's similar, so 60 plus 2x equals 94. So solve for x, you'll get 17. So it's pretty straightforward. Okay, so this one, using the diagram, A, B, C, where D, E, and F are the midpoints of all sides. Okay, so this one is the midpoint, 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 and then we connect all the midpoints. So DE, so that means it's parallel to BC, okay? Because this one is called the mid-segments of the base of this triangle ABC. And also we do know that FE, so FE, which is parallel to segment AB. So that means FE is the mid-segment of triangle of the base AB of triangle ABC. So in order to get that, the mid-segment, so there's always a formula. So 1/2 times the base, so that equals the measure of the mid-segment. So AB right here, so it's 14. So EF, which is the mid-segment of AB, so take half of it, so 14 divided by 2, so 7. And then AE, okay, so AE it's 8, and then you want to find out what DF is. So DF, again, AE, if you take twice as much as 8, then you'll get 16. Half of 16, then you'll get the mid-segment, which is 8. And then DE. Okay, so DE here, mid-segments of triangle, the base BC of triangle ABC. So if DE is 6, so this one is twice as much as the mid-segments, so 6 times 2. So then that'd be 12. So it's pretty straightforward. And then using the diagram, triangle MNO, where XYZ are the midpoint, so basically using the same kind of theorem to find out the missing line segment. So YZ comparing with that MN, so YZ, MN, they're parallel. Again, YZ is the mid-segments, so that means 3x plus 1, so that's it's 1/2 times MN, so 10x minus 6. And then solve for x, distribute, so we got 5x minus 3. And then isolate the variable, 5x minus 3x, we'll get 2x. And then 1 plus 3, then that'll be 4. So x, so that'll be 2. And then in order to find out what yz is, we just plug in a number back to 3x plus 1. So 3 times 2 plus 1. And then we'll get 7. And then the rest of this, they're quite similar. So using the mid-segments to find out the missing side right here. And then measure MON equals 48 degree. Okay, so MON, 48 degree. And then you want to find out the measure of MZX. So MZX. So if these two line segments are parallel, so that means those two angles got to be corresponding. So that means this angle is also 48 degrees. And then MXZ. So MXZ. So this one is 37 degree. So you want to find out that the other angle, MNO, again, corresponding angle, so 37 again. So for number 7, 3 or more line that contain the same point are called concurrent. So this one is just a repetition of what we just did. And then in center of a triangle, it's always bounded by the intersection of the angle bisectors. So quite similar to what we did. I think this one is just a duplication. Alright, so basically chapter 6, so those are the main concepts you guys need to know. The triangle sum theorem, exterior angle, finding the missing measure of this line segment by using the mid-segments, and also all the concurrency, okay, centroid, incenter, orthocenter, and also the circumcenter. Okay, so thank you for watching the video today. I'll see you guys next time.